Hello everyone, I am Garbett and this is my code for my calculator. So I have many sections, there are many sections of this calculator, but I'll go section by section. So section number 1 is the distance formula, which is used to find the distance between two different points on a graph. The formula for this is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Section 2 is the Pythagorean theorem, which is used when you have a right triangle and want to find the third side when two sides are already given. The formula for this is a squared plus b squared equals c squared, where c is always the hypotenuse of the right triangle. Section 3 is the slope, which is used to determine how steep a line is. The bigger the number, the steeper it is, which is also described as rise over run, where rise is the y value and run is the x value. The formula for this is y2 minus y1 over x2 minus x1. All right, then there's the quadratic formula, which is mainly used when you're solving a quadratic which is unfactorable by normal means. If b squared minus 4ac, which is this part, which is also known as the discriminant, is less than 0, then there will be no real solutions. If it is equal to 0, there will be one real solution, and if it's greater than 0, there are two real solutions. The formula for this is negative b plus or minus the square root of b squared minus 4ac all over 2a. Next is the average, which is used to find the middle of two or more numbers in a sequence. The formula is a sub 1 plus a sub 2 all the way up to a sub n all over n, which is basically saying the sum of all numbers over the number of numbers there are. Section 6 is solving for x, where we're trying to solve an equation with only one variable, and we want to find all the possible answers. This is used when the right side is equal to 0 and it is factorable, which is where we don't need to use the quadratic formula. Not all of these are even quadratic, as the exponent can be as high as it wants, and that'll display how many answers there are. For example, if the degree or highest exponent is 10, there will be a mass of 10 solutions. All right, now before I go to the next section, I want to quickly talk about factorials, as I don't think many of you know what they are. So factorials in math are the little exclamation point that are put after a number, which show that you are multiplying a number by itself and then itself minus 1 all the way up to 1. So for example, 4 factorial would be 4 times 3 times 2 times 1, or 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. This can get a little more complicated when you're using a term like x plus 2 factorial, which will turn into x plus 2 times x plus 1 times x minus 1, going on forever. Now that we know, now that factorials are taken care of, we can talk about permutations, which are used to find the number of ways something can occur when the order matters. For example, if you want to decide how many ways that 10 racers can get first, second, or third, you would use 10p, which stands for permutation 3, where 10 displays the number of racers and 3 displays the number of positions there are. The formula for this is n factorial over n minus r factorial. Then there's combinations, which are used to find the number of ways something can occur when the order doesn't matter. For example, if you want to find the way that 5 students can sit in 3 different chairs, that would use 5c, which stands for choose, not combination. 5 choose 3. The formula for this is n factorial over r factorial times n minus r factorial. And now we have arithmetic sequences, which is the first part of the last section, which are sequences that follow a pattern that either involve adding or subtracting. For example, 1, 5, 9, 13, and 17 would be considered an arithmetic sequence, where the common difference would be 4, as that is the difference between each. The formula for finding the nth term of a sequence is a sub 1, which is the first term, plus n, which is the term's position, minus 1 times the common difference. Finally, we have geometric sequences, which are which follow a pattern that involve multiplying or dividing. For example, 1, 4, 16, and 64. This is a geometric sequence where the common ratio is 4, as that is what you're multiplying each time. The formula for finding the nth term of a geometric sequence is a sub n is equal to a sub 1, as in the first number in the sequence, times r, the common ratio, to the exponent of n minus 1. And here's the link to my code. So I don't want to go into all of these. I don't want to go into every single one of them, but if anyone wants to see one in action, then if anyone wants, Mr. Moreau, if you want to unmute and see one of them.
Yeah, I appreciate that, Pierce. Excellent presentation so far. Why don't we try number 4, the quadratic formula?
Okay. So now that it shows what the formula is for what it should look like, and now it'll ask for A, B, and C. So give me if you would give me some values.
Okay, so I'm thinking in my head, before I give you the numbers, let me think. So x squared plus 7x plus 12. So it would have x plus 4. So the roots would be minus 4 and minus 3. So go ahead and put 1,
7, and 12.
7 and 12, and let's see if we get that minus 4 and minus 3. Okay, yep. Good.
And then it'll stop and say thank you for my calculator. And if you want to use it again, you can click run again.
Okay, so let's solve for x. Let's do number 6, see what happens.
So now it'll ask you to enter your own equation.
5x plus 10 equals 0.
You don't need to put the equals. This only wants the left side. It'll assume x is equal to 0. It assumes the right side is equal to 0.
Okay.
And then enter the variable to solve for. So you don't have to use x, but in this case we're going to use x. Okay. And there you go.
Wow. Very good. Very impressive. Okay. Very good. Now scroll down to the part where it solves the equations.
Which one? For 6, for solving for x?
Yeah,
right here. Whoop. There we go. Right there.
Okay, so it uses solve from SIMPy.
Yes.
Okay. Very straightforward. Okay. Okay, very good. Thank you, Pierce. Thank you very much.